The last chapter of Chem 101 is about acids and bases. We'll discuss acids and bases, the strength of them, ionization of water, and the pH scale. So acids can be defined by Arrhenius, and the definition of Arrhenius says that acids are those that produce proton ions, H plus ions in solution. They have a sour taste. They turn blue litmus paper red. Bases, according to Arrhenius, are those that produce OH ions, OH minus ions in solution. They have a bitter taste. They feel soapy and slippery, and they turn the red litmus paper into blue. Let's identify each one of these as an acid or a base. Sour taste is an acid. Produces OH minus is a base. Bitter taste is a base and produces H plus is an acid. Another definition that we're going to deal with is Prost and Lowry. Prost and Lowry say that an acid is something that donates a proton. A proton is H plus. A base is something that accepts a proton. So when we have an acid-base reaction, we will have an acid-base conjugate pair. This is an acid. It donated a proton. This is an acid. This is going to be its conjugate base. And this is a base, and this is going to be its conjugate acid. So the way that we're going to recognize a conjugate acid or a conjugate base, if we have a hydrogen, we donate it, we get rid of H plus. So we see that this compound over here was HF. It was neutral. We got rid of a hydrogen and a positive charge. So this is going to be its conjugate base. When we see water, H2O, if it accepts a proton, it accepts this. So it will have an extra hydrogen. That's why this one has 3 and an extra positive charge. So every time we have an acid-base reaction, we're going to have the base with its conjugate acid and the acid with its conjugate base. So let's write the conjugate base of each one of these. Remember that a base is something that will accept a proton. So we will treat each one of these as an acid, meaning that we'll subtract a H plus. If we subtract H from here, we'll get with Br negative. If we subtract here, we'll end up with just 1 negative, and in here it will be HCO3 negative. Now here we're going to write the conjugate acid, meaning that we're going to add H plus to each one of these. So NO2, the conjugate acid will be HNO2 because we are adding H plus. For NH3, it will be NH4 plus. And for OH minus, it will be H2O. So let's see, identify the conjugate acid base. So see here, we have 1 and we don't have it here, so this is an acid-base pair. We have 2 and we don't have it here, so this is not an option. These two are not even related. We have 1 and now here we have 2. This is an option, so this and this. Here we have 1, here we have 4, another option. Okay, so now this one. Conjugate base of this compound. Conjugate base will be getting rid of a hydrogen and adding an extra negative charge. So the answer will be A. Conjugate acid of this, meaning adding 1 hydrogen. So instead of having 1, we'll have 2 and get rid of the charge. Answer will be C. The conjugate base of water, remove 1 hydrogen and add a negative charge. And the conjugate acid of H2O will be H3O plus.